today we are going to review exponential functions. That does mean we're going to review properties of exponents, graphing exponentials, all of that all in one day. So this is like week of algebra 2 in one day. Tomorrow and the next day we'll spend 2 days reviewing logarithms and properties of logarithms. So we'll have a couple days on logarithms. So it's much more condensed than you learned in algebra 2, but we will spend some time what you learned in algebra 2 on exponential logarithms. So that's our first goal. Simplify and express using positive exponents only. So this slide is to remind you how properties of exponents work. That first slide is our set of rules. Don't make up rules, don't break rules. Okay? If you do that, you'll be good. One thing I want to mention before I go on this slide, just real quick. This right here does not equal a to the m plus b to the m. Okay? And that's a common rule that people make up.
Yeah.
Why does it not equal? Yeah.
Spoil it.
Yeah, to spoil it, you'd have to, if you were really doing to large power, you'd have to use the binomial theorem. You may remember Pascal's triangle and that binomial theorem stuff. But anyway, mention, don't make up that rule. It's not a rule. Okay, so how would I do w to the negative 8 divided by w to the negative 3? You could flip it. Then what? Subtract. So you can flip it and subtract, or if you don't find negative numbers, you can subtract from negative 3. Negative 8 minus negative 3 is negative 5. And then at some point, you get 1 over w. Any questions about that one? How do you deal with the next one? Okay, the negative 2 exponent goes with everything. Okay, the negative 2 exponent goes everything. So I have negative 5 to the negative 2. Can someone tell me why I left that in parentheses?
The negative matters.
The negative matters. And so I'll leave the negative out of the parentheses. That's a different number than if I put the negative in the parentheses. It was originally in parentheses, so I'm going to leave it there. How do I do x cubed? That's a negative 6. I do like switching things around on this one. All the negative exponents, move them positive. So I have negative 5 squared on the bottom, 2 squared x to the 6 on top. And what is negative 5 squared? 25. If I had not put those parentheses there, I would have got negative 25, which would be slightly incorrect. Okay? Because you square before you look at the sign. Please excuse my dear. No. You can't square root the top and bottom of a fraction. 2/3 is not the same fraction as 4. You can divide things out. Okay, the next one. What do you do? Okay, you can flip stuff. But even if you flip stuff, you're going to have to subtract and add. I'm just going to challenge your brain. I don't care how you do it. You can flip first if you want. I'm not going to, though. I'm just going to go ahead and add and subtract. But your way works great. I put a 1 there just to remind myself that that's x to the first power. First of all, the 8/6. What happens to 8/6?
4/3.
That's 4/3. I can do that. And then 1 minus negative 2. What is 1 minus negative 2? So that's x cubed. And what is negative 2 minus 3?
Negative 5.
Negative 5. If you were working this, you're welcome to skip that step. But, so this is 4x cubed over 3y to the 5th.
Oh,
You could have flipped it and then added. Would flipping and then adding be the same as subtracting a negative? Okay.
Can't break rules or make them up here.
Hey, everyone agree so far? The biggest thing people mess up on this one is they forget to read the exponent as well. Don't forget that it gets twice you. It does. Don't discriminate against seconds. So x to the 6 over 27 y to the 6. The negative is at the bottom, and then 3 cubed is 27. You're so much smarter than you used to be. Do you know how long this slide probably took you to do?
I mean, we're just. We're smarter.
Okay, the next one, a lot of ways you could do it.
Flip everything. It's easy.
If you,
Or just slap in your calculator. Why?
if you have to be able to do this back. Because you have not considered it.
Okay, then you just wing it then.
I'm going to add negative 3 and negative 4 thirds. Do not tell me you can't do that. How do you do that?
Put it
Make
some
some
numbers.
Good, I need a common denominator. It is okay to have to write it down, but there's a difference in can't and I would have to write it down to do it. Right? So yes, you might have to write it down, but if you can. Multiply by 3 on top and bottom, right? So I get negative 9 thirds plus negative 4 thirds.
Negative 13 thirds.
Which is negative 13. So I get 10 to the negative 13 thirds. Divided by 10 to the negative 13. And then I can subtract those. Now, you could do this in a different order if you wish. But I'm going to do negative 13 thirds minus negative 13, which is plus 13. And I need a common denominator of 3. 39, right? 13 times 3 is 39. 39 minus 13 is 26. So this is 10 to the 26. A lot of different ways you can get there, but one way.
I got a lot different.
You did?
Yeah, I got 10 to the 7th over square root of 10.
10 to the 7 over the square root of 10. 10 to the 7th over 10 to the 1/2.
Yeah.
7 minus a half. No.
I put it in front. Oh, wait. I'll be cube root. Never mind.
Over the root of 10. So 9.
Yeah, I messed up. I did square root.
9 thirds. Or 9 would be 27 thirds. So yes, yours is the same, but you're not completely. Does that make sense? So you change that cube root to 1/3 power, and then you'll be good to go. Okay, any questions about this one? No calculator. This comes up all the time in calculus. Yes, you need to be able to do this without a calculator.
Did you get 10 to 26?
10 to the 26 over 50. The biggest thing we need to know is, what in the world does a half exponent mean? Square root.
Okay.
Top powers on.
Is that including? Oh, wait, never mind.
Good question. And I have 2 different questions up here that most math students think mean the same thing. Do they mean the same thing?
No.
No. This one, the square root only goes with the 49, right? So this is negative square root of 49.
So it's always going to be negative.
Negative 7. This is the square root of negative 49, which is not real, right? We can call it 7i. I will tell you in calculus, we will just say no real answer. But we won't deal with i's and cal 1 and 2. But truly am doing this completely by hand, I have options. I can square root first or I can cube first. Which one is wiser? Square root first because then I get a small number. The square root of 16 is 4. 4 cubed is 64. Okay. 16. The top number is the exponent, the bottom number is the root. It would be the cube root of 16 squared, which would be something I can't simplify, but I couldn't do quite as easily as this, because 16 doesn't have a perfect cube root. What's a negative exponent? Good, it puts it in the bottom. A lot of people get those mixed up, half exponents and negative exponents. Remember, halves or fraction exponents do a root of some sort. Negative exponents put the number in the bottom. Okay, if I go ahead and do all of that at once. Square root of 9 cubed, which way is easier? Square root first. That's right. Okay. How fast do you know these things? Yeah.
And how many questions are there?
Okay, some more exponentials. This would have been a separate day in Algebra 2. So this is lots of things at once. Again, the next 3 weeks will feel like we're going fast because we are. And you know this stuff already. But if there's something you've forgotten, we can pick it up. Again, I'm not a miracle worker. If you didn't get it the first time and you still don't get it in this, come see me, and then I can be a miracle worker. But probably not here. The way this is structured is that you learned it and understood it at one point and have just forgotten it. That's the structure of this. But if you didn't understand it the first time, come see me so I can help you. Okay. So exponential functions, key information about exponential functions. I have a table here set up for you to fill out the table, right? A fourth. How can I do that so fast without a calculator? Properties of exponents, right? Anything to the 0 power is 1. That was one of those properties.
What? Appreciate it.
Okay, so an exponential function. Question. No matter how big of a negative number I put in, does this ever go to 0?
No.
Never go negative. So remember on the packet when it had e to the x and you factored it out and you're like, when does e to the x equal 0? And I said, it doesn't. How do I know that? I know an exponential function, you can't take a positive number and raise it to an exponent and make it 0. It just doesn't work. Which creates, graphically, a horizontal asymptote. The horizontal asymptote is a horizontal line that the graph approaches as x gets really big or gets really small. So the horizontal asymptote on a non-shifted exponential function is y equals 0. Again, if I shift up and down, that'll move the asymptote up or down. But the y-intercept on an unshifted exponential graph is 0, 1, because anything to the 0 power is 1. The domain of any exponential is negative infinity to infinity. And the range of any exponential is 0 to infinity, again, unshifted. If we shift that little, the range. Good. 0 has parentheses because I never actually equal 0, so there's no bracket there. If we are going to graph an exponential by hand, the first thing I would pick out is the base function. And on the base function, there are 3 points that are always there that are really easy to pick out. -1 and the reciprocal of the base, right? 0, 1, and 1 in the base. And so I can take those 3 points and then use those as my points to shift if I'm doing transformations. Questions about basic exponential function? So if I wanted to graph some exponential functions, 2 to the x minus 2, I would take that graph, the basic 2 to the x, 0, 1, 1, 2, negative 1 half. Take those 3 points and move them.
Right.
If I move left and right, does that affect the horizontal axis?
Yeah.
No.
What affects the horizontal axis? Moving up and down, right? Down.
Yes, bro.
Hey, negative 2 to the x, what does the negative do? Over what?
The x-axis.
Over the x-axis. What would it do if the negative was inside?
Over the y.
It would reflect the y-axis, so we can do all kinds of fun things. So, I didn't draw the original. Are y'all okay? About that?
I don't know.
That is the original reflected over the x-axis. So we could graph this about any exponential we want. Using those 3 points and transformations. This one is a different one. So we do have to come up with a different set of 3 points, right? The 3 points on the first 2 were from the bell ringer. But there are 3 points we can always pick out easily on an exponential function. 0, 1. Negative 1 and the reciprocal of the base. What's the base here? The reciprocal of it is. I think that y'all were answering now, right? So the base is 1 third. The reciprocal of the base is 3. That's what y'all. Is that what y'all were saying? And then the base is a third. So 1, 1 third. So those are my 3 points. Now I can move them. Everyone see how that works? Yeah. Find those 3 points, move them around. If you have to grab it back here.
So automatically 1.
See? It's not too bad.
Negative 1 is next.
Right, because what happens when you put negative 1 into an exponent?
Flips it.
Alright.
So negative 1.
Supposed to teach us that.
It's been a while.
No, she didn't. She made us graph everything. She didn't like tables.
You put this in a table.
Long right? She teaches this.
Right 2 up 1, right? Right 2
That's
up
why
1.
we're in the lead class.
Yeah.
We learned shortcuts.
You weren't last
Okay.
year. Hey, I would, if I were graphing this by hand, go ahead and put a dotted line for my horizontal asymptote. It did move because I moved up 1. Otherwise, you might drift and accidentally go below 1, but the horizontal asymptote moves as well. Oops. I'm still trying. I would teach this much differently if you were in algebra 2 as well. You can't go this fast now. Okay, if they hand you a worksheet, it's only got like 5 problems on it. This is a bunch of random assortment of problems. This is, look at page P17. Make sure that looks right. Make sure you don't need a calculus book yet. At some point, start assigning some problems out like calculus book, but I don't think so. Hey, here, these graphs look like, so make sure those problems look like exponential function problems. I'm sure. No, page P17, and then page 166. I think they're in. I think they're both pretty common. That looks like okay, good. And 166. Yes, do tomorrow. It's not that many problems. 4 through 20 every fourth. The worksheet, you only do the circle problems. I am not in this for busy work. Just enough to make sure you still know.
So there are no other methods. Is there other methods?
Some of those 3 points.
Oh, you.
Yeah. So there's points you can kind of memorize and know to expect. And you can plot as many points as you want if you know like the taking slow plots. Those 3 will give you a good shape. You know, if you needed more accuracy, you could get more accuracy about all this.